Good day. This is Bennett, also known as Jeremiah. Today I'm going to show you how to find the first and second derivative of parametric equations. If you are interested in similar type of videos, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So, let's begin. Alright, in order to derive parametric equations, you have to know this formula. The first derivative, which is derivative of y with respect to x, is equals to the derivative of y with respect to t times the derivative of t with respect to x. So you have to know this for the first derivative. Memorizing this will make the first derivative easier. Alright, in order to create the first equation, we first of all know that this represents the first derivative, right? Derivative of y with respect to x represents the first derivative. Now the problem is that we want to write it in terms of t. So the next thing that you're going to do is that you're going to multiply it by 1 so that you don't change it. But this 1 will be in the form of dt over dt. So we've just multiplied this by 1, which is not changing the value, we're only changing what it looks like. And then the next thing is that these two will switch places. So this one will go to this place and this one will go to this place. So this is what will happen if we switch places. And notice that this is already the equation of the first derivative. So there we have it. This is the first derivative of a parametric equation. The second derivative is usually represented as d squared y over dx squared. So this will be equals to the derivative with respect to t, and we're going to have derivative of y with respect to x, and then we're going to have times derivative of t with respect to x. So before we talk about the second equation, let's talk about this first. Notice that whenever you see d over dx and you have 2x, you already know that you have to find the derivative of whatever's inside, because this means the derivative of whatever's inside. Or if you see d over dx and you see sine x in the bracket, you already know that you have to derive whatever's inside, and the derivative of a sine graph is a cos graph. Another thing you need to take note of is that the first derivative is usually represented as the derivative of y with respect to x. Notice that the second derivative is simply the derivative of the first derivative. In other words, we'll say the derivative of the first derivative. So notice that already this is the second derivative. Now the problem we have is that we want to write it in terms of t. So in other words, we want to change what it looks like. So if we want to change what it looks like, we have to multiply it by 1. But that 1 will be in the form of dt over dt, since we want to write it in terms of t. And then what you'll do is that you will switch these two. Notice what will happen if you switch the two. This is what's going to happen when you switch the two. And notice that we already have our desired outcome. This is the second derivative in terms of t. So there we have it. So this is how to create the second derivative formula. So it's up to you. You can choose to memorize it straightforward, or you can choose to create them. So now that we dealt with the equations, let's move on to the actual questions. So you have to memorize these two stuff. So whenever you want to find the first derivative of a parametric equation, you use the first equation. When you want to find the second derivative of a parametric equation, use the second one. Alright, here is the first example. So we're given a parametric equation, x is equals to 7 cos t and y is equals to 7 sin t. And we're asked to find the first derivative. So by memorization, we know that the derivative of y with respect to x is the same as the derivative of y with respect to t times the derivative of t with respect to x. So this is what we have to memorize. So first of all, we have to find the derivative of y with respect to t. So let's find the derivative of this portion. So we'll say the derivative of y with respect to t will be equals to, now a constant times something is the same as the constant times the derivative of that thing. So it means that the answer will still have 7 in front. So let's find the derivative of sine t. So we know that the derivative of a sine graph is a cos graph. So therefore the derivative of sine t is cos t. So we've just found the derivative of y with respect to t. Now let's also find the derivative of t with respect to x. But you don't really have to find the derivative of t with respect to x. What you have to do is to find the derivative of x with respect to t. Then I'll show you what to do after. So let's find the derivative of x with respect to t. So we're going to use this information because it pertains to x and we want to find the derivative of x. So we'll say the derivative of x. So the derivative of x with respect to t. So now we know that the constant times something is the same as the constant times the derivative of that thing. So our derivative is still a 7. Now what is the derivative of cos? The derivative of cos is a sine graph, it's negative sine. So we're going to have times negative sine t, because we're deriving with respect to t. And when we further simplify it, we're going to end up having negative 7 sine t. So let me just write this over here. So notice that we've got the derivative of y with respect to t, and we also have the derivative of x with respect to t. So far this part gives us this part. But as for this part, we've got a slight problem. The problem that we have is that we want the derivative of t with respect to x, but instead we have the derivative of x with respect to t. So when you have this and you want to get the derivative of t with respect to x, it's just simple. So now notice, whenever you've got a situation, let's say 2 over x is equals to 5 over 4. Notice that there is a principle in solving for x. You can actually switch the left hand side whereby whatever is down goes on top and whatever is on top goes down. So whatever you do to the left, you do to the right. So it means that we're also going to switch the right side of the equation. So this is what you do when you're solving for x. It's one of the skills when you're solving for x. So one of the skills is where you switch the left hand side of the equation and you also switch the right side of the equation. So that skill is what we're going to apply here. So we'll simply switch whatever is on the left side of the equation. So meaning that derivative of t will go on top and derivative of x will go down. And then now here, when we've got this stuff, notice that there is actually an invisible 1 because this is the same as over 1. So it means whatever is down will go on top and whatever is on top will go down. So that's what you have. So there we have it. We have found the derivative of t with respect to x. So now that we have found it, we can simply substitute this part into this part of the equation and substitute this part into the other part of the equation. So let's proceed. So we're gonna say derivative of y with respect to x is equals to, this part is actually this information, so it means that we're gonna say 7 cos t, and then this part is actually this information. So this is gonna be times 1 over negative 7 sine t. So since we have a fraction here, it means that this must also become a fraction so that we can multiply them. So now when you multiply fractions, this will just multiply 1 and that will just give us 7 cos t. And then this part will also multiply. So when they multiply, that will give us negative 7 sine t. So now notice that we can simplify this equation. So 7 and 7 cancels, so now we're left with negative. Now notice sine over cos is tan, but cos over sine is 1 over tan, meaning that it's cot. So we have cot t. So it's that simple. Always remember to use this equation. When we're talking about the first derivative of parametric equations, we just use this equation. So you have to find the derivative of y with respect to t, which is just using this part. And then we have to find the derivative of t with respect to x. But we find that by first finding the derivative of x with respect to t. So when we use this equation and find the derivative of x with respect to t, we just switch them and it will give us this information. And all you do is just to substitute the information into this equation and then you simplify it. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. Tutorials are offered in any mathematical or statistical module. It is also offered in native courses which start from N1 to N6. The video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. So our answer for the first derivative was negative cot t. So what about if they asked of the second derivative? What about if they asked for the second derivative? So according to our memorization, we know that it's going to be second derivative, right? Whenever we want to find the second derivative, it's going to be second derivative is equals to d over dt. And then we're going to have times derivative of y with respect to x, right? So it's d over dt times the first derivative. And then we're going to have times derivative of t with respect to x. So this is the other equation that we have to memorize. So now notice that this part is simply the first derivative. It's just simply your answer that you got for the first derivative. So it is that easy. So this means that we're finding the derivative of this part. And then dt over dx is just the derivative of t with respect to x. So far we can substitute. We'll just say d over dt. And then we'll just substitute our answer in place of that. So our answer is negative cot t. And then for this part, we already got it before, but let me calculate it again. So we just have to find the derivative of x with respect to t. So if we find the derivative of x with respect to t, if we derive this part, is going to be derivative of x with respect to t. And then we're going to have 7, right? And then this part, the derivative of cos t is negative sine t. And then this part will end up giving us negative sine, so negative 7 sine t. So far we have dx over dt, which must be equals to this stuff. So this stuff is the same as over 1. So when we switch the left hand side of the equation, we're going to have dt over dx, and then we're going to have to switch the right hand side of the equation as well. So it's going to be 1 over negative 7 sine t. So now we have this part again. So now we've got negative 1 over 7. So negative 1 over 7 sine t. So that's what we have. So how do we find the derivative of cot? If you're in a TVET college, you're usually given a formula sheet. But if you're in university, you are told to memorize this table. So generally, I would advise you to know this table. Memorizing this will make trigonometry in calculus easier. So as you can see from the table, the derivative of cot is negative cos x squared. So the derivative of cot is negative cos x squared. So it means that this part will give you negative cos x squared. So we're going to have negative cos x squared t. Now notice that there is another negative. So if you want to, you can put brackets and put another negative and deal with it later. Or if you want, you can deal with it immediately and just make it positive. So let's just rewrite this part over here. So this is going to be negative 1 over 7 sine t. So notice that this gives us positive. So it gives us positive cos x squared t. And then we're going to have multiplied by negative 1 over 7 sine t. So whenever you've got cosec or cot or sec combined with either sine, cos, or tan, you have to change cosec, sec, or cot so that you can be able to simplify the whole thing. So we know that cosec is 1 over sine. So cosec is the inverse of sine. So cosec squared is 1 over sine squared. So this is going to end up being this little 1 over 7 sine t. So always remember that cosec is 1 over sine. And then sec is the inverse of cos. And then cot is the inverse of tan. So these are basics to memorize. So multiplications of fractions, we've got numerator times numerator, which is going to be 1 times -1, which is just -1. And then sine squared times 7 sine is the same as x squared times 7x. So we're going to have 7. We know that x squared times x is x cubed. So sine squared times sine should be sine cubed. So that's how it is. So this is our final answer. We have found the second derivative of a parametric equation. So always remember that whenever you're finding the second derivative of a parametric equation, this part is simply the answer you got for your first derivative. And this part means that you have to derive whatever you see in the bracket. And then this part means that you have to derive this portion, and then you have to switch it so that you can find the derivative of t with respect to x. If you're interested in knowing how to find the equation of a tangent to a parametric equation and also finding the second derivative of a parametric equation if it exists, I encourage you to watch the next video of the playlist, which is at the end of this video. Alright, we have reached the end of this video. I've included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.